Hey guys, welcome to Cambridge Guru channel. We have started A-level pure mathematics series. In that we have already covered chapter number 1, first topic, polynomials. Our chapter number 1 is algebra. In that we have covered polynomials. So the next topic in this is the modulus function. So let us see what this modulus function is. The modulus function of x, which is denoted by mod x, is defined by that this function will be equal to x if x is greater than 0 and it is minus x if we have x less than 0. We pronounce this as modulus of x with these two vertical lines, and inside this we have just of any function x. So the output is positive if the number is positive, and it is minus of x if x is less than 0. Let us understand what this definition says. We might have encountered this term which is called the absolute value. So if I ask you what is the absolute value of minus 3, so what we did, if you remember in the previous classes, is that we put this minus 3 inside these two vertical lines. So basically we are interested in finding out just the magnitude of this minus 3. Okay, so absolute value means the minus sign changes to plus sign in simple words. Okay, so it is asking just the magnitude of minus 3, which is just plus 3. Okay, and obviously for any positive number the absolute value will be plus 4. Okay, means if it is plus 4, so absolute value of that will be plus 4. If it is plus 3, absolute value will be just plus 3. Okay, so what we understand from this is that whatever goes inside these modulus function, the output is always positive. Okay, these two vertical lines, they remove the negative sign and they produce an output which is always positive. It cannot be negative. You must have got confused with this minus sign, that since the output has to be positive always, so why this minus sign is there, this minus x. But if you look closely, it says that this is minus x if x is less than 0. Meaning is that in this x is already negative. Okay, and there is a negative sign outside this, so negative into negative becomes positive. Okay, so that's why the modulus function is defined to be like this, that output is always positive. If input is positive, then output is positive, but if it is negative, so we give a negative sign, we attach a negative sign to this number, so that minus minus becomes positive. Okay, so let us look how the graph of this function mod x looks like. Figure number 1 shows the graph of y equal to x. Y equal to x is a straight line whose slope or whose gradient is plus 1, means it is making an angle of 45 degrees with the x-axis. Okay, so what this definition of mod x says, that y equal to mod x, this is y is equal to x for all the positive values. Okay, so if we look in the second graph here, this second graph is y equal to x line for all the positive values of x. But the moment this x becomes negative for less than 0, the graph changes from plus x to minus x. Okay, as it is evident from this graph. Okay, this graph is y equal to minus x for all the x which are negative. Okay, so we obtain a V-shaped curve like this, whose corner is at x equal to 0. Okay, whose corner is at x equal to 0. If I have to write in detail, I can write this as x minus 0. Okay, minus 0 means this is the corner point of this V-shaped curve. Okay, so second thing is, you will look closely here that y equal to mod x, it is just 1 over x minus 0. that y equal to x line, and for all the values or for all the portion of the graph which is below the x-axis, it gets reflected in the x-axis. Okay, if I reflect this graph y equal to x, which is below the x-axis, and for the values of x, if I reflect this in the x-axis, you will get a v-shaped curve which is of mod x. So what this mod x function do, what this modulus function do to this graph is that it reflects the graph which is below the x-axis, and all the portion which is below the x-axis, it gets reflected in the x-axis. Okay, so there is nothing which is below the x-axis which indicates that y cannot be negative for every values of x or for any value of x. Okay, so we obtain a v-shaped curve for y equal to just mod x. Not always we obtain a v-shaped curve, it depends on the graph, it depends on the function. Okay, if the function is y equal to x square and then we are taking a mod, so it means something else. Okay, for example, if you have to draw the graph of fx, any function with the modulus sign, right? So what we understood from the previous concept, that if you have to draw the graph of any function with the modulus sign, you just reflect the portion of the graph which is below the x-axis, okay, and pull it upwards, means reflect the graph which is below the x-axis along the or in the x-axis. This x-axis will act as a mirror. Okay, so in this graph, in this function, we have original function as y is equal to x minus 2. Okay, so let us quickly sketch these graphs, this straight line y equal to x minus 2. Here the slope is +1, gradient is +1, and y-intercept is -2. Okay, so let us say that this is our straight line. Okay, this point is y equal to 0, x is 2. Okay, this is your x-axis, this is your y-axis. Fine, and this point is -2, your y-intercept. But this is just y equal to x minus 2. Okay, if we have to apply the modulus sign like this, what we need to do is the portion which is below the x-axis, it gets reflected in the x-axis. Okay, so we just reflect this point, reflect this portion, and draw the graph like this. Okay, so this yellow plus this red, you will get a v-shaped curve of x minus 2. V-shape is only possible if we are drawing the straight lines. Okay, and we can omit the portion which is below the x-axis. Okay, this is just a dash line. Okay, right, so here the point is +2. So if I ask you what is the y-intercept of mod of x minus 2, so it is not -2, because if you open this according to the algebraic, you can say definition, what we can do is, this is +2, we can open this up, that y is equal to x minus 2 if x minus 2 is greater than 0. Okay, according to the basic definition, whatever is inside these two vertical lines, this will be equal to that value x minus 2, right, where x minus 2 is greater than 0, and it is minus of x minus 2 if it is less than 0. Means if input is greater than 0, so output will be equal to input, and if input is negative, then we have to attach a negative sign to that input, right? Y equal to x for x greater than 0, y equal to minus x for x less than 0, basic definition. Okay, now you can simplify this, that my original function has to be x minus 2 if x is greater than 2, and it has to be minus x plus 2 if x is less than 2, right? That means we have two straight lines. One is x minus 2 for all the values of x greater than 2, which is denoted by this red line. Okay, and then the graph should be minus x plus 2. So as you can notice here, that y-intercept is +2, and its slope is, its gradient is -1. Okay, so minus x plus 2 line is this yellow line. So we obtain a curve y equal to x minus 2 mod, v-shaped curve. Another thing you will notice here is that if we have to draw the graph of y equal to mod x on the same graph, let us draw the graph of y equal to mod x like this. Okay, slope will remain same, so you can see that these two lines are parallel. These two lines are parallel. Okay, because the gradient of these two lines will be +1. Okay, hence these are appearing to be, in fact, they are parallel. Fine. So what you can notice from these two graphs is that this graph blue one is of x plus 2, sorry, not of x plus 2, it is just mod x, and this is mod of x minus 2. So what you can notice is that this blue graph is shifted towards right by how many units? By 2 units. Okay, and if you can remember from IGCSE that we have learned transformations, and one type of transformation is just the translation of the graph. So basically y equal to mod of x minus 2 is the translated graph of y equal to mod x, and it is translated by 2 units towards right. Right, if you remember, any graph which is shifted towards right, it is, we have to write in place of x as x minus those many units. So here the graph is shifted 2 units, so instead of y equal to mod x, we will write mod of x minus 2. Had this been x plus 2, that means the graph has to be shifted 2 units towards left. Okay, if you remember from translation from IGCSE. Fine. Third point you can notice here is that this corner point is this 2. Okay, as I have discussed earlier in the definition, that this mod of x can be written as x minus 0, where this 0 or anything that you are subtracting from x, this will be the corner point. Here this is the origin, and in this we get x equal to 2. Okay, so this was our corner point, x equal to 2. Okay, so these 2 or 3 things that you should notice, and this corner point you can obtain just by removing the sign and put whatever is inside these two vertical lines equal to 0. You will get x is equal to 2. As we can see from this graph, from the next function, which is y equal to 2x minus 3. Okay, so if you have to sketch the graph, let us sketch this quickly. Y-axis, x-axis, this is x. Okay, so I can remove these two signs and write 2x minus 3 as equal to 0. So I will obtain as x, which is the corner point, as 3 by 2 or just 1.5. Okay, so here let us say this is our 1.5 and this is 1.5, and the slope of the straight line will be plus 2. Okay, plus 2. So let us sketch this straight line. Let us increase the slope from 45 degrees to 10, whatever is the slope, means the gradient has to be increased from 1 to 2. So it should not look like 45 degree. So let us say this is our 2x minus 3 for the values which are greater than this value 3 by 2. Okay, and the second graph will be of minus 2x plus 3, because we have to attach a negative sign. Okay, so slope will be negative of this slope, which is minus 2, and y-intercept has to be plus 3. Okay, so the graph will look like this. Okay, let us point this point of intersection as just plus 3. Okay, so here also the y-intercept is not minus 3. Okay, as it is, you can say that it is evident from the function that 2x minus 3, and if you compare this from y equal to mx plus 3, mx plus c, so c is appeared to be minus 3, but it is not. Y-intercept is plus 3, right, by applying the modulus definition. Okay. Now here are some 1 or 2 algebraic properties from these modulus function. One is that if a and b are real numbers, then modulus of a into b is modulus of a into modulus of b. Means you multiply first any two given numbers, whether positive or negative, and then take the magnitude. The result will be equal to that you first take the magnitude and then multiply. For example, that you can take one value as -3 and second number as 4. So you multiply -3 and 4, which is -12, and take the modulus sign. So answer is +12. So this is your LHS, right? A into B then mod means -3 into 4 is -12 mod, which is +12. And if I have to find out the value of RHS, so modulus of A is 3 into 4, which is 12, which is equal to RHS, hence verified. Okay, that means this modulus sign can be separated and can be applied to individual numbers only if two numbers are in multiplication and if they are in division. Okay, because second part says that A divided by B then modulus is equal to modulus A divided by modulus B, and obviously the denominator should not be equal to 0, right? Otherwise it will be called as undefined. So modulus sign can be separated only in case of multiplication and division. Okay, this property will not hold in case of addition or subtraction. This is not equal to mod A plus mod B. Please remember this. Okay. So these are two algebraic properties that you should remember. Next topic is modulus on the number line.